concepts that we learned in our previous video are introduction of square roots, properties of square roots, finding square root of a number by repeated subtraction, finding square root of a number by prime factorization. To know more about these concepts, refer this link. This link will be shared in the comment box. The concepts that we are going to learn in this video are finding square root of a number by long division method, square root of a rational number, squares of terminating decimals, square root of terminating decimals. Now, let's see how to find a square root of a number by long division method. The steps to be taken to find square root of a number by long division. First step, mark of the digits in pairs starting with the ones digit. Step 2, think of the largest number whose square is either equal to or less than the first pair starting from the left. This digit is the quotient as well as the divisor. Find the remainder of the division. Bring down the next pair of numbers down next to the remainder. This becomes the new dividend. Add step 6. Add both divisor and quotient and enter it as a divisor with a blank on its right. Guess a largest possible digit to fill the blank, which also becomes the new digit in the quotient, such that the product of the new divisor and the new digit should be lesser than or equal to the divisor. Step 8. We stop the sum when the remainder is 0 and there is no pairs left. The digits in the quotient is the square root of the given number. I hope everyone have confusion on this method. To make it easier, let's solve some problems on how to find a square root of a number by long division method. Now let's solve a sum on how to find a square root by long division method. So we take the number 120409. So we pair the number first. 12 as a pair, 04 as a pair, and 09 as a pair. So what do is we draw a line and write these numbers 1204 and 09, and we should guess the largest possible number for the number 12. So 3 into 3 gives you 9. If you do 4 into 4, it comes to 16, where it is not possible. 12 minus 16 is not possible. So 12 minus 9 gives you 3. And here we have to add 3 plus 3, which is 6, and derive it as a new divisor 6 and put dash. And now we have 04 down with 3, and we have to again guess the largest possible number. So 68 into 8 will give you 46, 45, 44, which we cannot write here. So you have to try with 65. 65 into 5 gives you 64 into 64 gives you 6, 1, and 25, 256. So can we try with 65 into 5? So 65 into 5, 325. Yeah, 325. We cannot do it here. So we can you cross check. Yes, 5, 2, and 32. 325. Yes. So we can only write 4 here. So 4, 4, and we write 256. 304 minus 256 gives you 8, 9, 4. Yes, 48. So what you're going to do is you have to add this new divisor 64 and the quotient only the 4. Yes. So 64 plus 4 will give you 68. That's the new divisor. After writing the 68, we have to put the dash, and we have to bring the 09 down with 48. Yes. 4809. Yes. We have to again guess the largest number under which should be lesser than 4809. So let's try with 687 into 7. So it comes as 4809. Yes, it exactly can. So 687, 4809, 0. When the remainder comes as 0, we stop the sum here. So we put 7 in the quotient, and therefore 347 is the quotient there. and quotient is the required square root of the given number. So square root of 120,409 is 347. Simple, right? Square root of a rational number. Important rules to find a square. Step rule 1. When perfect square are a and b, square root of a into b is equal to square root of a into square root of b. When perfect squares are a and b, square root of a divided by b is equal to square root of a divided by square root of b. Rule 2. Let's see how to find square root of a rational number. Let's take the number 5, 18 by 19 by 25. So 5 into 25, 125 plus 19, 144 by 25. Yes. So square root of 144 by 25 is nonetheless yes 144 by square root of 144 by 25 is nonetheless square root of 144 by square root of 25. Yes. And then we write it as square root of 12 into 12. Yes, 12 into 12 is 14. So square root of 12 into 12 by square root of 5 into 5. 5 into 5 is 25. And the answer comes as 12 by 5. We can write it as 2 by 5. It's our wish. So square root of 5, 19 by 25 is 12 by 5. Squares are terminating decimals. There's a trick to find the square root of a terminating decimal. Let's learn that through an example. 0.0 for square is equal to 0.0016. So in the digit 0.04, after the point, there is only 1 0 before the digit 4. So if this decimal is squared, after the point of the digit, 1 0 changes to 2 zeros before the number, and the number after the point of the digit is also squared. Example, 4 into 4 is equal to 16. So we now understand that 0.0 for square is equal to 0.0016. Let's solve some sums on squares of terminating. Let's see how to find square of terminating decimals. So our first sum would be 0.09. So 0.09, we have to double the zeros here. So only 1 0, we have to write it as 2 zeros and double, and we should write 9 as 9 into 9, which is 81. So we write it as 0.0081. Let's solve another sum to make our understanding easier. So 0.007. We can write it as 0. We have to double the 3 zeros as 6 zeros. And we have to double 7 as 7 into 7, which is 49. We have got to write it as 0.000049. Yes, it's very easy, right? This is one of the easiest steps and a trick to find square root of terminating decimals. Now let's see square root of perfect square numbers in decimal form. Let's learn this concept through some sums to understand it easily. Now let's see how to find square root of a decimal number which is a perfect square. So we have 147.1369. So we have to write it as, we have to first pair it 147.1369. Yes, you have to pair it as 1 as a pair, 47 as a pair, and 13 as a pair, and 69 as a pair. Yes, so first we write 1 in the divisor and the quotient as we did in our long division method. So after we do this, we have to derive the new divisor 1 plus 1, 2, and we have to bring down 4, 7, so 47, and we have to put 2 there because 22 into 2 gives you 44, and we have to write the 2 in the quotient, and 47 minus 44, 3. And now we have to bring down 1, 3, and 22 plus 2. Yes, 2 from the quotient, and 24 dash as a new divisor. And now you have to multiply it with 1, because if we multiply 242 into 2, it comes as 484, which we can do. So 241 into 1, 241. 313 minus 241 is 72. So we bring down 69. Yes. We bring down 69 and 7269. And we add 241 plus 1, which is 242 dash. So we derive the new divisor as 242 dash. And I hope we can write 3 there. So 2423 into 3 gives you 7269. So we write 3 in the quotient and in the dash. So 3 and 7269 minus 7269, the remainder is 0. So the sum ends here. Our quotient is the required square root of the given number. So 147.1369 is 12.13. I hope it is very easy to find the square root of a decimal number which is a perfect square. It is similar to the long division method, but we have decimal here.